All right, CNT120, we're working on Chapter 2, and we're getting towards the end of the chapter, talking about operating procedures, asset management, and so forth. So operating procedures, this is documentation that's going to cover these aspects of our network: the logical physical connections, inventory, IP address, vendors, that sort of thing. These kinds of things, I show you examples of the next couple pages, is also important to document in your network. And this might actually be part of standard operating procedures too. Standard operating procedures are how we do certain tasks in our company, whether it be backing up data or recovering from a virus, or implementing a new software update, those kind of things. What procedures do we do for these aspects of our business or our network? So other items to consider in network documentation: your hardware. What kind of hardware do you have? Maybe the versions of, the iterations of, the model numbers of. What kind of software do you have? Again, what types of software, what version, or what edition, if you will, of that, and things about that. Where are they, upgrading of, updates of, that sort of thing. Network configurations of things like your switches, your firewall, your routers, your access points, those kind of things in your network, and where are backups stored or end up, how do you do backups and how do you restore from backups? One of the labs we do on 125, I show you how to use a TFTP server to back up network configurations, network switch and router configurations. Maybe that's part of your plan, and maybe even how you're naming these, router name, location, date of, etc. All part of a procedure on how to do that. And on that issue about procedures, how do we do certain things? How do we do the saving of? How do we do the naming of? How do we do the updating of? What's the procedure we use for that? Contacts for your different vendors. You often have different vendors for different aspects of your network. It might be who you get your equipment from, routers, switches, etc. Contacts, addresses of, contact information of, etc. Can also be contacts for things like your electric, water supply, alarms if you have fire alarms, and those kind of things, your alarm systems in your building. Who are these contacts? And then any sort of special instructions. I alluded to some of these earlier: backing up things and securities, safety restrictions, etc. This is all part of your documentation in your facility as well. Now, being the new person somewhere as you walk in, a lot of these things are already in place. You would need to get up to speed on them and eventually be part of maybe updating or writing or documenting some of these things, because things do change. It's not going to stay the same. So getting up to speed, and then you might actually have responsibility of updating certain parts of this, or checking, verifying that it's up to date, that sort of thing. Inventory management. One of the jokes Mr. Brown uses is, when you're the new person somewhere, a lot of times they will hand you a spreadsheet of equipment and have you go around and check, is this printer in this room, and what's its model number and what's its serial number? Check it off. Go to the next room. And you're literally verifying the equipment is where it says it is. And if it's moved, updating that documentation, where is it? Well, that might be a job that you do, but you also might be using software to help with that too. There is software out there to help you identify where certain things are, and or the versions of. This computer is running this version of Windows, this version of Office, etc., etc. And letting you know and keeping inventory of that to know these groups of computers need to be updated, these have been updated, etc. And maintaining serial numbers, MAC addresses, all those kind of things. There's resources out there to do that, to help with all of that. They remind us about some tips for labeling. I need to have enough information on it that I know what it is, but I don't want to have a label that's 39 characters long and doesn't fit on a label. So going back to maybe some company standards. Maybe the company standard is, the first two or three characters indicate the building. The next one's the floor. Next one's the closet. That kind of thing, or the port number on something. And they might have a couple characters for each part, and then that gets used in a naming convention here. And this might even be, building 1 closet A versus building 1 closet B for closet 2 kind of thing. And this might be the patch panel and the port number. That might be enough to get by, but using a naming convention and then using your labeling utilities and labeling equipment to label all the cables, label all the ports, etc. That's the kind of things they're talking about here. If necessary, you draw diagrams of and start labeling ports and maybe specifics about that. And this can be a real simple router diagram. Or you have a switch diagram. It can even be a spreadsheet showing all the ports and what they're connecting to. So there's different ways to do it, but having some sort of standard way to do that. Next section of chapter they get you familiar with some business documents, and that's the key, just familiarity. Request for proposal is just that. You want to have a certain thing done, and you send it out to a couple of vendors saying, hey, we would like to have this thing done. What is your estimate on costs to do this? And it could be put new cabling in a building. It could be get rid of the old wireless system, put a new wireless system in. It could be replace all the printers with new printers. That kind of thing. So you contact a couple vendors of like, hey, what's it going to cost to do this? What would be a proposal to do this task? And they send them back to you. And then as a company, you wade through those 5 or 6 proposals and trying to find the not always the cheapest one, but kind of like the economical one that's going to do what you need to have done, and hopefully well. There's a memorandum of understanding. Oh my goodness, that is literally, hey, we intend to start working on this together. Have a contract that we're going to do this task together, this project together, or we're going to contract you to do this particular task for us. That's your memorandum of understanding. Master service agreement. Terms that would have between the two parties, agreements on how we're going to do certain aspects of business. You're going to do this with our database system with our customers and so forth. We need this new system in here, so we need you to do A, B, and C. This is what we're going to do. This would be the task that we're going to be doing, and that's the contract we're going to hold you to. Statement of work is just that, what work is to be completed. It might be to come in and take out all of the old blah and properly dispose of them. It might be to come in and take those out but put new ones in of a certain thing for your company. And then service level agreement. Service level agreement sometimes is through your ISP. We are paying for blah bandwidth, and if we have an outage, we need it to be restored in blah time, and that would be an agreement with your provider of like, this bandwidth, this availability. If there's an outage, repairs in blah amount of time, and having things back online quickly, and that would be your agreement with them. Last part of the chapter, they talk about kind of anticipating failure. Our devices will eventually fail. So how are we planning for that? Well, fault tolerance is trying to plan for that and minimize the likelihood of a failure, or minimize the amount of time that a failure would affect our business. And failure is a car breaks down the highway. That's a failure. But the fault might be the water pump broke, which caused the car to fail. So a fault might be, a switch dies, which causes a whole portion of the network to not work correctly. So how do we plan for that? Well, the fault tolerant system goal is nothing ever fails. And that usually is pretty unreasonable, but you can get darn close to that. Having things in place to get back and working quickly. Well, the devices we buy, routers, switches, etc., have a rating on them of mean time between failures, meaning it is likely going to run, 24 hours a day, 7 days a week for blah days. And it could be close to 7 years that it's designed to run before it's going to fail, theoretically. So if I have that and I put that in place and I make a plan to replace or upgrade that in 3 or 4 years, I'm hopefully beating the odds of that failing or running that too long that it's going to fail. So I look at that and look at that as part of my replacement cycle. The mean time to repair is, well, how long do you think it's going to take to replace that thing and get the network functioning? Well, let's say it is a switch failure. I might need to go to the closet, unbolt the switch, pull it out, put a new switch in, plug it in, plug all the ports back in, and then put a config back on. Well, that could take, I might need to drive to the Lancaster campus and do that. It might take me 2 or 3 hours. If that's unacceptable, then we need to have something else in place that would reduce that time. How long is this going to take to repair? Maybe I have a redundant switch in the rack ready to go, but that's going to cost money to do that. Okay, that's all part of the redundancy game. Ideally, I would have a redundant piece of equipment there running, ready to go, that I could just move my cables in. So my mean time to repair is, minutes versus hours. But it's going to cost money to do that. And we're back. My apologies. That was a phone call. So with redundancy, yes, I can build in some redundancy, but it's going to cost more money. And so they bring up the idea of single points of failure. If you have a network design like so, router into switch, switch into firewall, and ISP, these are what they call many single points of failure. If my firewall here, fails, the whole network's down. If the router fails, whole network's down. If the switch fails, whole network's down, kind of thing. So that right there is, cost effective to put in place, but it could be costly if something fails. A solution could be doing some redundancy. Now, it's going to cost more to have redundant equipment, redundant connections. However, if there is a failure on one of these, your network is still functioning, and there is literally no time to repair, if you will. You have the luxury of replacing that failed equipment. So I don't have any loss in money in business, if you will, with the network being down, but I have the cost of adding that redundant equipment in. So that usually you're trying to find a happy medium between the two. What would be necessary to keep us running in a scenario? And it might be in a smaller business, you literally just have a redundant router, switch, or firewall sitting on the shelf that you can get it off, put it in place, configure it within like an hour or two, and have your network up and running. Versus having to wait to order it and have it delivered, or going and getting it delivered, and have your network down for a day or two. That might be the cost-effective solution, kind of the middle of the road. There is some things you can do, automatic failover. In a network like this, you can actually configure like these networks to run in tandem, that if something fails, the other one's already there running and kick in. That can be done, and you can even have, in some cases, hot swappable parts. Some of our devices, you can literally pull a part out, put it back in without having to power it down. So some things, having hot swappable parts could be handy. Or having a hot spare or cold spare. Hot spare is just that, like we have here. It's configured, running, ready to roll. And I might just move, if I don't have 2 redundant connections, I might just remove the redundant connection from the failed side to the working side, kind of thing, or the backup side. And I can also have a cold spare, which we said earlier. I might just have these equipment sitting on the shelf that I can pull off the shelf, unbox, plug in, and get rolling. That would be a cold spare. And that's kind of like the cost-effective backup method for like a small business. And we could even do, I mentioned this in here, you can even do some link aggregation, which allows us to, if you have a connection between switches, you can have a redundant connection there and have them work together. That way, if a port fails or a cable fails, the other one's already there and running. So you don't lose the connection between the two. The last part of the chapter, they talk about system life cycle, and actually planning for the implementation of, and then a timely replacement of that and disposal of. We said before, if you have your mid-time between failures, if you know a switch is good for like 7 years, you might start planning on replacing it at year 3 and 4, and try to get it out and get a new one in there and functioning before the potential failure. And that would go for all of your equipment, your computers, printers, routers, firewall switches, access points, etc. Planning for all that to be done in a timely manner. And that's what they mean by this life cycle management, which is the last little piece of the chapter here that they talk about.